Good morning, ladies and gentlemen. We start the first session of the day. The topic is IoT, Empowering Smart Cities Infrastructure. Our chairperson for today is Mr. N.S.N. Murty, Partner Smart Cities, PwC. Mr. Murty is the Smart Cities leader for PwC India. He has over 18 years of Indian and global experience in strategy, project delivery, P&L management, and smart cities. As a thought leader on smart cities, he designed several projects in the area of smart cities, public safety, urban transportation, and sanitation. Prior to PwC, he was with EY and IBM, wherein he worked with clients to deliver components of Smarter Cities framework. He has worked extensively across Indian subcontinent and Middle East on several key initiatives. May I request Mr. Murty to come up on the dais, please? Can we have a round of applause? Thank you. Our keynote speaker is Mr. Ali Hosseini, founder and CEO, SenRa. Mr. Hosseini, can I have you on the dais, please? We have presentations by Mr. Martin Woolley, Developer Relations Manager, EMEA, Bluetooth SIG. And the panelist, Mr. Arul, can I have you on the dais, please? Mr. Ravinder Singh and Mr. B.Sivakumar. Now I'll hand it over to you to conduct the session.
Good morning, everyone. It's freezing, first of all. Okay, so I'll be a little bit shaking. Just pardon me for that. Thank you so much for inviting us, all of us here, the organizers. And I welcome all the speakers and my co-panelists. The topic is about IoT infrastructure. How do we use that to empower cities, networks, infrastructure, smart elements, use cases? The entire discussion is around these elements. Now, it was about 4 years back, 2015, when Government of India launched the ambitious Smart Cities mission for 100 cities. In the last 4 years, the cities have, in their progression of selection, they have actually started consuming the technology to deploy projects and infrastructure. Over a period of time, in last 4 years, slowly and steadily, and for sure, everyone has realized the amount of sensors which are getting deployed in the cities is far higher than whatever we actually talking about in terms of mobile phones or data or anything, the number of sensors which are getting deployed at the city level. So how do we actually start utilizing the data which is coming from these sensors, this infrastructure? How do we actually make them talk to each other? How do we actually look at the legacy sensors with the new sensors, and what are the standards? These are the questions which are now coming forward. We are actually looking at, India has always been actually saying that let's do the pilots, let's do few of the projects, let's learn from those projects and then start building stuff. So I think we are in a right place and opportunity for everyone across the globe to actually look at cities, look at the urban infrastructure where the IoT infrastructure has been invested in and supposed to be invested in future. How do we use emerging tech to use that existing infrastructure and the future one to make sense and solve some important civic challenges? I'll take two small examples, and that's where I will leave my other speakers to start having a word here. One, can you think about a city which is mosquito free? A city without a mosquito. It's an ambition. It's something which is everyone wants to do it. When the Smart City Challenge was in progress in 2016, we were actually asking about what is a vision of a smart city. And we went to a school, kids were talking about it. The kid said that, and this is from them, actually one of the kids said that, why should I get dengue every year when I know that in this month the dengue is supposed to happen? Still I get a dengue, or my friend gets a dengue and he actually gets sick and I'm not able to play with him. So it's a known phenomena. Few of these which are known phenomena, how do we actually use the technology to solve it? And I've seen a couple of startups, and I encourage all the panelists also to start looking at these startups. Startups who actually looked at identification of mosquitoes, their gender, their breed, They look at how the larvae formation happens in stagnant or the fresh water, all those parameters based on computer vision, AI, mark it with drones as an engine to run, and provide those solutions. So this is something which we have not thought about, but someone actually is thinking about how do we use the city IoT infrastructure to solve something which is very rudimentary but the most important problem. The second is, how do I actually give access to skill-based education in slums? You know, the most important thing in India is not about how do I actually give a water or a sewerage line or any other facility in a slum. It's important from a civic infrastructure standpoint. But please think why people from rural areas or semi-urban areas have moved into cities and living in the slums, because they have a higher aspiration level to do good, better in life. They wanted to actually come to city for jobs. They wanted to actually get more income. So if these are the aspirational people and we add the skills on along with that, imagine the kind of employability opportunities we can create. But the point is, how do we educate or provide skills in a slum area? Another company came and another startup and firm, they said, okay, how do I actually create an IoT integrated education systems on the mobile plus their vicinity-based services? I actually start beaming these classes or a skill-based classes to their homes. Everyone owns a TV or a mobile phone. And the second one said, I will train them only on drones. So today we have a drone mechanic, or today we have a mechanic, we have a construction worker or a bricklayer or someone like. Drones, if they can do the same work, someone needs to manage the drone. So I upskill these guys who are 10th, 12th pass or even 8th pass, they know, and I know that they know how to play games on their mobile phone. I can help them train and skill them on drones. Manage those. A drone cleaner, a drone repairer, a drone operator, a drone storekeeper. Imagine the kind of skilling of the new skilling which will happen. So these are the two. So one, how do we use the existing infrastructure, put standards to it, make sure that it is made open to everyone, startups, any other competing firms, everyone, make that good for the civic infrastructure solutions. And the second is, how do we solve simple but large magnitude problems using this infrastructure? So I will stop here and I'll invite Ali. Ali is founder and CEO SenRa. And Ali, all yours. And how much time?
Hello, everyone. How are you? I can't hear you. How are you? Ah, great. We're alive today. So I'm really excited to be here and talk about smart cities infrastructure, Internet of Things. It's stuff we do every day at SenRa. And I'm also interested to hear opinions from our extinguished panelists here because as you'll start to hear in this segment, a lot of different pieces of the overall puzzle come together when different companies with different technologies are solving the core issues that are implemented by smart cities. So the first thing I'll do is show a quick video on SenRa to kind of set the stage on what we're doing with smart cities. You'll also notice in the video some core challenges that we're trying to solve as part of these smart city efforts and other companies as well. So let's see if this will play successfully.
Why is it that, in today's technologically advanced world, we're still struggling with the basics in life? Clean air, water, energy. Shouldn't these be somehow fixable by technology? They should, and they are. SenRa is a low-power wide-area network provider for IoT and M2M applications, a solution that provides connectivity in the remotest of places, reliably and securely, so that your data is always safe. Whether you're looking for smart water solutions to tackle the global water crisis, smart agricultural solutions to get the best yield from your crop, air quality control, or to construct smart buildings and cities, every street, every parking lot. Imagine a world that's completely connected. SenRa.
So a few key points in there. You noticed a family walking with a mask due to air pollution. You also saw discussions quickly on energy, metering, parking. A lot of these core infrastructural issues that are trying to be addressed by public and private entities to make India a better place. So what do we see here? Just a little step back on the IoT market for India, and this is a number that a lot of people have seen out there now at several conferences. NASSCOM came out with a report, $15 billion US market by 2020. So now we're in 19 and we're not that far off. And as what you'll see is, hopefully what I'm able to explain is the smart cities segment is a big portion of that market opportunity. Also, the DOT had come out and stated by 2022, you're going to have 5 billion devices in India alone connected. What does that mean? How do we get to those 5 billion numbers? And one of my thoughts is the smart city efforts. So as a businessman, when I decided to open up the company here in India, one of the key driving factors was these projected numbers, the sheer size of devices that could be connected through the smart city efforts that you see support from the mission, the smart cities mission out there. So it's quite an interesting challenge, but I think we can achieve these goals with the smart city efforts. And so you look at what is the government doing to support the smart city efforts here in India. So the cabinet had approved $14 billion US of funding towards the smart cities mission, revitalization, and other development efforts towards cities, smart or not. And what that is doing, it's bringing in interest and driving up market opportunity. And so we look at tenders all the time for smart parking, street lights, smart water metering, and the sheer size of numbers, you're looking at one city for 90,000 smart meters, another city that is 30,000 street lights. These numbers are going to continue to increase as more cities start to implement their RFPs and flip them as a tender basis. And this funding here is a really critical piece to drive those efforts. What we've also been able to determine as the smart cities market, it is expected to reach a almost $48 billion US market opportunity by 2023, with a compound annual growth rate since 2017 at about 18.5%. That is a massive market, and this shows the funding from the Indian government, the projections by the DOT are driving this massive uptick in the market adoption for smart cities. And if you step back from India, in the overall global scene, the IoT analytics research, they interviewed over 1,600 companies that are involved in enterprise IoT, and they asked them what are their main projects in 2018, what is driving their business. And over 23% of the response was smart city efforts. So the global market is also heavily invested and reaping their benefits from the smart city segment. Second to that is industrial IoT and then connected building. And I believe you'll hear more from some of our speakers, our next presenter on connected building. That also, in my opinion, kind of intertwines with the smart city efforts because part of your core infrastructure is smart buildings. So just the top three alone is another good showing for the market opportunity. You'll also see the APAC piece on smart cities is about 18%. And it's still trending upward. So this is backdated to about 2015, 2016, and they continually show trending upward. And it's just continued to get better. what we've seen from 2015 to 2018, a lot of POCs were done, a lot of pilots were done with IoT and smart city efforts. What I'm projecting in 2019 and 2020 and beyond is these pilots and POCs to actually turn into real commercial projects, real commercial field deployments, and real connectivity that's actually being used to solve these core smart city infrastructure elements. So what is the smart city infrastructure elements? If you look across the globe at smart city policies and guidelines, this actually came directly from the Smart Cities Mission's website. You'll see 6 core elements that all smart cities around the world are focused on. One is urban mobility, which is related to traffic congestion, parking, transportation, metro systems, you name it. Energy management, you know, the grid, smart lighting, smart street lighting, and so forth. Water management, consumption of homes, big utilities pushing these waters, the quality of water, waste management. We see in Delhi the efforts that are starting to take place in waste management. How do you decompose the waste properly using IoT technology? And then the final 2 is e-governance and health and education. So these core elements are really the foundational driving factor of this 5 billion device connectivity, which I think the majority of the connections will actually come through this effort. What I tried to do is to make a little bit more sense from a technical perspective without just blowing your guys' minds out with all these crazy diagrams. So this is a 30,000 foot level look at what a smart city infrastructure needs from a technology perspective to support those deployments on those core elements. You start at your sensor level, your device level. If it's a mobile phone, if it's a Bluetooth beacon, if it is a LoRaWAN sensor, these devices are going to be the core communicating sensing that's taking place. So then when you receive that information, you're sensing properly. How does that data get sent? You need that core infrastructure, that network. So what we do at SenRa is we deploy LoRaWAN network infrastructure across India. We're currently, I think, in 34 cities, and we're deploying infrastructure on rooftops and on towers to support these sensors and devices so that they have a means of communication. You also have the traditional telecommunications infrastructure. You have Wi-Fi that's being deployed and a gamut of other technologies. Once that data has a means to send its information, you now need to then go to the management services, the data streaming, the layer that allows you to take the data, keep it secure, and route it properly and store it properly until it's needing to be processed by an analytics platform, which is that second to top layer. So then you do analytics, you do data visualization, and you have business management systems all integrated to give the smart cities, the decision makers, and these enterprises a true insight on what those sensors are doing and how can it benefit their businesses. And then finally, as we talked about the 6 elements, the core applications, what is the citizen needing? Is he needing an app for monitoring his water consumption at his home? Is there a free app for submitting your tax registration information online for e-governance? Can you talk to a doctor through an app? Can you find a parking lot? So those things are the application layer. And all of this data reports to elected officials, municipal employees, and obviously the public. And in parallel, this whole entire process has to be considered from a security perspective. Is the data encrypted? What is high-risk information, high-risk systems that could be hacked? You have to keep that all locked down. And then taking the localization out of the picture and making sure all of this process is stored in the cloud with proper artificial intelligence and processing. Yes. 2 minutes. Yep, almost done. So this is a look at all of the different types of technologies you hear. How do you understand what technology to use if you're doing a smart city requirement? And I found this off of the Barcelona website, the Smart Cities Guidelines. This is a matrix that gives you an insight on all of the different technologies, not all of them, but some of them, and what a city is looking at when they have a use case or a requirement they need to address, and based on that, they generated this matrix to show different technologies. I highlight LoRaWAN because that's what we support, but also you can see that it's probably one of the better technologies for probably 70% of smart city deployments. And you'll also see that in India, 70% of the technology that's starting to be deployed and have market growth is the low-power wide area network technology. As of 2018, it had a 70% market growth. And to wrap up so that I don't eat up too much time, this is solutions that we've deployed. 4 out of the 6 core elements that I talked about have been done by SenRa and are being done by other companies, from water management to intermanagement to urban mobility and waste management. And then I'll finally end it with a smart use case project that we did in Amritsar. This is sensors sending information to infrastructure, routing it to the cloud for analytics. And we also developed an app that allows that sensing to be given to the police officers so that they can then go to the parking sensor, issue a ticket to reduce traffic congestion. And it was deployed in Amritsar. The public, local media did an article on it. So you'll see on the bottom part, the police officers pointing to the actual sensor installed. To the right of that is the parking app that the police officer has on his phone, and he gets a notification when someone trips that illegal parking spot, and then the command control center, the police department, can log in and actually see the analytics. So thank you. I'm sorry if I went a little bit over. I'm really excited to hear what we all have to say, and if you all have any questions, feel free to send us information at these email addresses and follow us on Twitter and that thing. Thank you so much.
Thank you, Ali. May I now invite Martin? Martin from Bluetooth SIG, and I was reading his profile, and he said Bluetooth he's found out phenomenally useful for the age group that he is, or everyone right now. So probably you want to start from there, Martin. So I'm just giving you a curveball initiative.
Thank you very much for that introduction. Hello, everyone. So again, I'm Martin, and I work for an organization called the Bluetooth Special Interest Group. I'm aware that not everybody knows who that is. They've heard of Bluetooth, the technology. So Bluetooth is a standard. It's governed by a set of specifications that all the manufacturers must follow so that devices work together. That's interoperability. And my organization's job is to be a hub to own that specification process, to progress the technology through its evolution and so on. So we're a standards organization behind Bluetooth, but we don't make things, we don't make products, we don't make software and so on. We just decide how it all works, and other people do what we say. So Bluetooth itself has been around for 20 years now, actually. It was 20 years old last year, so it's a very well-established technology. It's in everything, nearly, not quite, but very nearly everything. Still thriving. Figures are growing every single year. Don't see any sign of that big kind of leveling off so far. And at the moment, we're seeing, these are last year's figures, 10 million devices every single day with Bluetooth in them shipping. It's not a typo. I had to check that one. 10 million, it's enormous, like 4 billion devices every year. So it's very, very ubiquitous. And one of the technologies that developers tend to naturally turn to for all sorts of connectivity requirements that they need to meet. Now we actually have 3 Bluetooth technologies now. We don't necessarily brand them separately, but technically there are 3 different flavors of Bluetooth out there. BR-EDR, that's the formal name for the original type of Bluetooth. Lets you create point-to-point connections. It's a cable replacement technology. Still very strong in areas like audio. If you've got audio, if you've got wireless headphones, that's probably using that type of Bluetooth. Bluetooth Low Energy is probably the best known these days, though. It's probably where all the action is these days. Bluetooth Low Energy is very power efficient, very common to find devices run off small batteries for years. It lets you form point-to-point connections as well, but it also can broadcast, so one device can communicate with many other devices simultaneously. And then the newest of the Bluetooth technologies, which is really what I'm going to talk about today, is Bluetooth Mesh. Now, Bluetooth Mesh lets you create networks of tens of thousands of smart devices. And it's designed for a variety of things, including smart buildings, which I'll come on to. Not everyone's familiar with the concept of mesh networking, so let me start you off there. So, 3 keywords for you to remember. There will be a test before you leave the room, so listen carefully here. Multi-hop, multi-path, and multicast. 3 words beginning with multi. Usually in wireless communications, 2 devices must be in direct radio range to be able to communicate. That makes sense. Move out of range, communication stops. That's not the case with mesh networking. One device will send a message addressed to some collection of destination devices, and that message can travel across the network by hopping from device to device to device, a process we call relaying. Now with Bluetooth Low Energy, which is the radio powering Bluetooth mesh networking, the range between individual hops is hundreds of meters, and you can do up to 127 hops. The message travels at the speed of sound through the network approximately. So with 127 several hundred meter hops, you can cover a very large area with a Bluetooth mesh network. Certainly an entire office block, an entire business campus, and I know of projects that are looking to deploy Bluetooth mesh networks covering whole neighborhoods. Multipath is about reliability. Reliability is very important. It's very hard to achieve as well, especially in large buildings. So one of the multiple strategies that are built into the design of Bluetooth mesh for achieving reliable communication concerns multipath. If a device transmits a message, it actually sends multiple copies of that message simultaneously, and they travel through different paths through the network to their destination. So if one path is broken for some reason, there's a physical barrier somewhere, doesn't matter. Another copy of the message will arrive at its destination via a different path. Any other copies that arrive just get ignored. So that's about reliability, it's architectural redundancy. Multicast is this. Bluetooth mesh is designed on the assumption that most, if not all, operations will involve one device talking to multiple other devices. One switch on the wall controlling all the lights, for example. One sensor talking to multiple other systems. That kind of multicast communication is very hard to do unless you design for it from the beginning. If you get it right, though, you end up with a very, very scalable solution. Because with Bluetooth multicast addressing capability, one tiny message of maybe 30 bytes could control 1,000 other devices. 30 bytes transmitted through the air very, very quickly. So Bluetooth mesh in the first instance was designed for smart buildings. I was in the room for the first ever meetings that we had on the subject where we were looking at requirements. So the kind of use cases we were thinking about were monitoring and control of smart building systems, improving things like energy efficiency, introducing and implementing automation scenarios, and allowing buildings to become self-optimizing environments, very energy efficient, creating great work environments for people who occupy them. Not just designed for smart buildings, it's in smart buildings today. And here's an example for you. There are lots of them out there now, but this one's in Texas, just one I happen to know about. Existing building, all sorts of varying requirements, lots of rooms with different kind of characteristics and different uses in terms of how people use those rooms. Some with windows, with natural light coming into the room, some without. Lighting is very central to smart buildings. I'll say more on that in a moment. But Bluetooth mesh was really effectively used to meet the varying requirements there, leveraging automation capabilities that are built into the specification, leveraging the way that sensors can work as an integral part of your smart building solution. Now, there's a really interesting idea, a vision, if you like, that the lighting industry has for smart buildings that I like very much and like to share with you. It's the idea that smart lighting can be a platform. And it goes like this. So smart lights consist of some hardware, obviously, possibly some integrated sensors. They certainly have a microcontroller. That's why it's a smart device. That's what makes it programmable. There's a Bluetooth mesh stack, so it can communicate. And there's what we would call the application layer. Now, it's the application layer software that makes the device type that it is. It's what makes it a light. It's what makes it possible to switch it on or off, change its brightness, change its color, and so on. That's the application layer. The story could end there, but in the smart lighting as a platform vision, the question arises, why can't I have more than one application running on my smart light? It's a programmable device. It runs software. Why can't I do that? And the answer is there's no reason why you can't do that. With sufficient memory, you could run 2 or 3 distinct applications on your smart light. You look at the ceiling right now. I want to see heads do this. Look at the ceiling. I'm a control freak, forgive me. Look how many lights we have here. Lights offer a natural connectivity grid in buildings. They're permanently powered. If they're smart lights, you have a distributed network of programmable nodes that you can run a variety of building services on. So lights will become IT infrastructure, not just a way of providing illumination in a room. They'll do things like provide asset tracking capabilities, where Bluetooth-equipped devices can be tracked through a building. I've had meetings with global companies that make things like power tools, household names you have heard of. They're embedding Bluetooth transmitters in their power tools so you can never lose them. Leave it in a room somewhere in this new construction site, the lighting system will tell you where it is. Asset tracking in buildings, courtesy of smart lighting as a platform. Indoor navigation, wayfinding, they can provide those kinds of services as well. And all sorts of other things we haven't thought of. One of the great things is we create the technology with certain requirements in mind, and then people like you come up with other ideas for using it. So that's an exciting vision the lighting industry very much likes. That kind of idea doesn't come to pass magically, automatically, doesn't just happen. Ideas are one thing. The technology underpinning ideas like that, though, has to have certain qualities and capabilities. And first on my list is interoperability, which I already mentioned. Interoperability is freedom. It's business freedom. It lets manufacturers, it lets building designers, architects, and so on select devices from multiple manufacturers, safe in the knowledge that they will work together straight out of the box. Interoperability is central to everything that my organization does. And it's about meticulous attention to detail. We define absolutely everything, and we can define everything because we own the specification for the entire stack. Other wireless communication systems, it's not the case. They own this many layers and they sit on top of some other standard. They don't control that. They don't have the option to change it because it's not theirs, but we own everything. So we define everything from the way radio waves are used to encode information, analog, low-level things, right up to the way products behave and talk to each other. Everything. That's how interoperability is achieved. Scalability, obviously critical. You hear vendors talk about this stuff all the time and make all sorts of claims. My advice to you is this: not all wireless communications technologies are the same. The devil is in the detail. You have to look at the engineering detail to understand and appreciate why a technology like Bluetooth Mesh is as scalable as it is. Now, the key, I could talk about this for a long time, but we don't have time. The key factor in scaling when it comes to wireless communication is actually how efficiently you use the radio spectrum. If you're sending large packets slowly, then the transmitting device is owning that frequency for a long time. No one else can transmit because you get packet collisions, things fail, scalability starts to be impacted. If, on the other hand, you're transmitting tiny packets to achieve the same result, using a very fast radio, you're using the radio spectrum, that frequency, for a very short time. There's lots of space for other devices. You get much greater scalability. So Bluetooth Low Energy, which is the radio that Bluetooth Mesh uses, is the fastest low-power radio that there is. 2 megabits per second possible. Most of the others are restricted to 250 kbits per second and can't change that because they don't own the lower layers of the stack, so they're stuck. So we're way faster, and the packets, the PDUs that Bluetooth Mesh uses, were purpose-designed for these kinds of applications. So we're talking 30 to 40 bytes of data for 90% of all the things you'd ever want to do, transmitted very quickly. Small packets, fast radio, that's how you get scalability. And we use multiple frequencies as well, not just one. So security, again, big subject, short of time. Bluetooth Mesh security is mandatory. No individual manufacturer can reduce the security of their device and therefore the security of the network. That can't be done, not allowed. All messages are encrypted and authenticated, so you can't fake messages and inject them into the system. We separate network and application layer concerns, different security keys used for those two areas of the network's operation. We can physically and cryptographically isolate different physical areas. Imagine hotels with hotel rooms. You want the occupant of one room to be able to control the smart devices in that hotel room, but not, of course, those devices in adjacent rooms. It's the same network, it's the same hotel Bluetooth mesh network, but we can cryptographically draw a boundary around each hotel room using Bluetooth mesh security capabilities and so on. So security was designed from the ground up for Bluetooth mesh and meets the requirements as we understand them. Last but not least, developers. They're important, right? They're critical to the success of any technology. With 10 million Bluetooth devices shipping every day, not surprisingly, we wanted to make sure that existing developers could create solutions to Bluetooth mesh. So existing Bluetooth APIs, as available on mobile platforms, desktop platforms, and through the web browser with Web Bluetooth, can be used today to create Bluetooth mesh applications for things like monitoring and control. Most Bluetooth mesh scenarios involve machine-to-machine communication, switches and sensors talking to air conditioning units and things like that. But people are important too. People need data and information. And as a consequence of this support for existing APIs, developers are creating solutions right now. So how does it work? In 2 minutes, I'll give you a couple of things just to give you a flavor. First of all, I've already mentioned messages. It's a message-oriented communication system. The specification defines all the message types relating to all the various types of operation that can be carried out in the network. It uses something called publish-subscribe, not an idea that we invented, very commonly used messaging paradigm. In summary, the way it works is this. If we use lights and switches as an example, when I install and configure my devices initially, I'm going to do two things. For the switches, which will publish or transmit messages, control messages, I'm going to tell them the address that they must address those messages to. That's part of the publishing process. I'm going to say to the switches over there, you must publish your on-off messages to the conference hall A group address. So we have a group addressing scheme. And that's all I tell them. Use that address. The switches know nothing about the identities of the individual lights they're controlling. When I install each of my lights up on a ladder or some scaffolding, I'm going to configure them so that they listen for or subscribe to messages addressed to conference hall A lights. Okay? So each light knows what sort of message to respond to, but it doesn't know the identity of the switches that will send those messages. So the two are decoupled, they're separated from each other. And the benefits, it's very simple. I can make changes without needing to reconfigure everything. If I add another switch over there, I just tell it about the conference room A address, nothing else. I don't need to tell it about the lights in the room. If I change one of the lights or add another light, all I need to do is tell that one light to listen for those messages. I don't need to change the other lights in any way at all. And that's not the case with lots of other systems. Hotels can have tens of thousands of lights, so this sort of stuff, it matters. Last guided tour. One thing I've not really talked about is how application level kind of product behaviors are supported by Bluetooth mesh. So we have the concept of a model, and a model is really a standard specification for individual product behaviors. And what a product can do in the network is a consequence of the combination of models, Bluetooth mesh models, it implements. So as a Bluetooth mesh product designer, you're going to be selecting the models that your product must have to give it the capabilities that it needs. So here's an example. I've got a light switch, I've got a light, and I've got a sensor. Each of them has a number of Bluetooth mesh models inside them. If we start with the simplest possible requirement, I want to be able to switch my lights on or off wirelessly across the network. So I make sure that my lights have something called the generic on-off server model. It's a software component that lets me switch them on or off. Very simple. And the switches all have the generic on-off client model. It's a client-server relationship. The client can send messages that mean switch on or off. Very simple. That's one set of requirements met. Lights have more complex requirements. Lights are much more complicated than most people realize, it turns out. I want to control the brightness of my light, but I know that human beings' perception of brightness in lights is not linear. So I have a special model called the light lightness server model that allows me to change the brightness of lights in a way that's perceived as linear by people, even though it's actually not linear. Okay?
Steve, 2 minutes.
Thank you. HSL, that's about color control, hue saturation and level. So that model lets me control the color of my lights. Let's bring the sensor into play. We have a sensor server model which works with any type of sensor that I know about, and it works with a special model for lights called the LC server model. LC is lighting control. Models have relationships, and it works almost like a spreadsheet. If a value inside one model changes, then any related value in another model will automatically get recalculated. It's called a state binding. So here's an example. Imagine I have ambient light sensors in the room. They're measuring the light level in the room every second or something like that. What I want is to keep the light level at a steady state throughout the day. And that ambient light level is a consequence of the brightness of the artificial lights and the lights coming in through the windows. We don't have any today, but you know what windows are. So the way it works is this. The sensors are measuring the light level. They're publishing a message to a group address, which communicates with all of the lights in the room. The LC server model in each of those lights receives that data and says, hang on a moment, it's getting darker. I'll tell the light lightness server to turn up the artificial lights, make them a little bit brighter to compensate. Or alternatively, it's getting very bright in the room now, the sun's streaming in through the window. I'm going to turn the lights right down or even completely off. So we're keeping the light level in the room consistent, which is great for our workforce, let's say, but we're also being very very energy efficient. Almost got that the wrong way around there. This is all happening very subtly, very quickly, very, very subtly. People aren't aware that this is going on. It's called daylight harvesting, by the way, very common requirement in smart buildings. So where next? With 20 seconds to spare, if you want to know more, write this down, www.bluetooth.com. Remember that? Good. If you go there, we've got lots of stuff. That's where you'll find the specifications, of course. There are 3 specs covering Bluetooth mesh in total, divided into sort of various areas. We have some papers that make for very good reading. If you're interested in going a little bit deeper but not spending too much time, I recommend something called the Bluetooth Mesh Technology Overview. You'll find it very easily. It's like 20 pages. It's a 30-minute read. If you're a developer or a technical person or you have developers working for you, we have hands-on educational developer resources where they can actually start to do some coding, really explore and understand Bluetooth Mesh with a view to looking at adopting it in products. And that, my friends, is it. I think we don't have question time now. We'll have it later on. But thank you very much for your time and for listening.
Thank you, Steve.
Thank you.
Okay. That has been a really interesting 2 different technologies, outside and inside the building. So I think we'll have a lot of questions. But before everyone from the audience have a question, I have a couple of questions for other panelists. So I have Sai Arul on my right-hand side. Sai is from IBM, and he focuses on the public sector, safety, technology, and infrastructure. So Arul, you heard the new stuff, new technology happening. And I know IBM is working on all these aspects for a long time. Anything that you specifically would like to mention, what is happening around the IoT-based analytics or IoT-based use cases that IBM, Watson, or whatever you can actually think about is looking at solving the civic issues? I'm particularly looking at the use cases which IBM is solving.
Thanks, Murty, and my predecessors on the panel. See, the bottom line is the entire concept of why we are going into the entire domain of smart cities is, the bottom line is to improve the quality of life of a citizen. Now, and the reasons are obvious, be it the universal phenomena of globalization where over 50% of the world's population is in cities, and there is a limited space that's available in a city for growth of its infrastructure. So the basic aim is to optimally utilize whatever existing infra is there, or build infra in a manner which improves the quality of life. And in both these domains, the basic aspect that is required is the ability to analyze the problem of a city and plan for it, plan the operations or the infrastructure of development in a more holistic and optimal manner. Thereafter, operate it and maintain it in a manner which is optimal. And the ability to even react in case of a breakdown of that infrastructure in case of a disaster. And the basic issue involves, that comes up is the ability to utilize available information to be able to optimize its utilization in terms of deployment. So what I'm trying to impress upon is that while my predecessors in the panel, they spoke a lot about, the devices, the technology to communicate, connect them. The basic outcome of any smart initiative is to optimize the utilization of the data that is being collected. That's the ultimate aim, with basically to improve the quality of life, right? Now, when we come to optimization, there is the entire planning process where inputs based on requirements can help optimize how the infrastructure should be laid out such that it is optimally utilized. The second is whether you can draw some insights out of it such that its utilization can be optimized. See, for example, a transportation problem, it is both optimization and a scheduling issue. If it's public transportation, the scheduling such that it takes care of inputs like peak travel hours, directions of travel, all those aspects are an analysis issue. And analytics goes beyond just the initial planning. It goes beyond, it goes into the domain of scheduling, optimization. Then we come to the higher end, which is the predictive part, where outcome can be analyzed in advance and planned for. Thereafter, it is the entire disaster management piece where, given a situation, you can paint pictures that something goes wrong, how does one react to it, thereafter the recovery. So the analytics domain covers all these phases: the planning phase, the operations phase, the disaster phase, the maintenance phase, and the predictive part to plan it. And that's where organizations like IBM are doing seminal work. And we go into the domain of artificial intelligence, machine learning, the cognitive aspects of handling this massive amount of data that is being generated by all these devices, the ability to make sense of it. That's where the entire actual value comes about of going smart. The entire concept of the Internet of Things, so much of data, making sense of it is the actual, the cream of what we're trying to achieve.
Great. Thanks, Arul. RP, let me take completely jump from where Sai has left. So he said IoT analytics on top of it, how the sensors are throwing the data, how I make it meaningful. We hear that, and we actually are looking at few of the use cases around that also existing in the cities. We also are looking at emerging techs like artificial intelligence. I just touched upon that and couldn't complete that. But how do we look at converging these two? Because one is throwing up a data, and second is actually mining that and making some kind of a patterns, understanding it, and trying to give some answers in advance and helping the citizens. So anything which is in the governance situation, in the citizen governance models and everything, where you can actually look at a confluence of these two.
Yeah, sure. So, thanks. Artificial intelligence has, I think, become the next big buzzword after IoT and smart cities, and I think it's catching up very fast. But it's practical. Now, when I say it's practical, let me take an example. We have been having IoT in its present format or earlier format when we started with M2M and making things smart by connecting. And then having data in real time which can be analyzed and meaningful insights you can drive. Now, artificial intelligence has taken it many steps ahead, and I'll give you a couple of examples. One of the examples in a country like India we always face is traffic. Too much of traffic, traffic compliance, traffic challan systems and all. And we have been having systems and solutions in place for last couple of years in terms of intelligent traffic management system, which helps police and traffic to maintain. But at the same time, when we now look at artificial intelligence getting into this, one of the startups, I work very closely with startups, we mentor them and we incubate them and we also help them grow. So one of the startup has created a beautiful artificial intelligence based system which takes the feed from CCTV camera on a traffic signal, same CCTV what you already have today, the data which is already there, so they are not neither regenerating that nor reinventing that. What they simply do is they use an algorithm basis which they can track every minor compliance and what I call criminal issue originating from that video. It can be as simple as how many people riding a bike. And it's so fast and so nicely, you know, I wish I could have shown you a video, but you can Google it and you'll find it. Within seconds, milliseconds actually, you actually get a report in a video format which tells you how many bikes, how many people on the bike, are they wearing helmet, are they not wearing helmet. If they are not wearing helmet, then that gets tied to the bike number so you can generate a challan. And if I did a practical test because I asked them a simple question, you know, this is where artificial intelligence is going. I said, okay, now if I am riding a bike, what will happen? In the first instance, the software actually made it non-compliant, saying I'm not wearing a helmet, so there's a challan to be generated, which was not the right thing. Within 2 hours, they came back, rectifying the system and said, now it can actually say whether you're wearing a helmet, not wearing a helmet, or you're wearing a turban, so you don't need a helmet, you don't need a challan. You know, such is the meticulous algorithm and minute details that this software putting across the city now can within seconds generate a report at the end of the day how many challans they can send or how many vegetable vendors are actually encroaching the road, how many vehicles are going the wrong side. It can tell you each and everything. That is the kind of flavor artificial intelligence brings on top of what we are doing today. And that's why we coined a new word for that, by the way. IoT has been there, Internet of Things. We said, okay, Internet of Things coupled with artificial intelligence, it actually becomes intelligent quotient of things. So I call it IQT, not IoT. IQT takes a couple of notches ahead when it says that you have the data, you have connected the systems, you have the data coming out of the systems in real time, you are doing edge analytics in real time, and then you are putting a layer of artificial intelligence on top of that, which actually sums it all. And that is where we created a model as well, which is called 8C model of IoT connectivity, which talks about 8 C's: connect, collect, collate, compute. Compute is nothing but analytics. Conserve, communicate, consume, and finally change. So these 8 C's model actually changes the way we look at problems today, whether it's traffic, whether it is ambulance going on the road, traffic lights, sensing that and clearing all the traffic corridor without even manual intervention. Yeah. So the way artificial intelligence is entering every aspect of our lives through IoT, smart cities, smart buildings, smart homes, and you would have already have Alexas and Google Home, which is like one step. But we have to go further. In next 3 to 4 years, believe me, 2 things I can vouch for. Number one, you will have many intelligence systems around you, which will be voice-enabled, gesture-enabled. You don't have to really sit and do. Second, and most important thing, what will happen in next 3 years, going by the startups and going by innovations happening in this country, we will have so much of solutions that we'll be able to export a lot of these to foreign countries. So that
Thanks.
That sums it all.
Great example, Arpi. Shivakumar, again, so we are, I think that your firm looks at both the things, which is the sensors, the use cases, and as well as the intelligence part of it. So, but I have a little bit of a tangent question, and when I met your MD also, that's the same question. How do you use this light infrastructure, street light infrastructure, which you have deployed for a city, for example? You build all these. are you actually deploying it, for example, on a LoRa network or any other networks, or are you actually solving any other civic use cases than the street lighting? Because that's given, that's your bread and butter. But is there anything beyond this you're doing using your infrastructure? So that's something which if you would like to tell us.
See, the thing today, when you talk about smart cities, one of the most prevalent things is smart lighting. Because now we have LEDs all over, and therefore it's electronics, and any electronics can be controlled. That's where you're now having the genesis of what is happening in terms of smart city lighting. Now, when you deploy a smart city lighting, and in many of the smart cities, you're talking about individual street light controls. Now, these street lights are normally around 25, 30 meters apart, which means that you have a very large, wide, dense network of street lights, which you are individually controlling for various purposes. So you have formed a sort of what's known as a lighting backbone. The question is that why don't you think about using this lighting backbone to carry the data from other services, from other sensors? And that is eminently possible because one of the primary requirements of any sensor to operate is power. Now each of these streetlight poles are powered, the lights are powered. And normally when you talk about controls, we have a communication device, a controller on top of each streetlight. And this is communicating with the data concentrator unit or a gateway and then going to the command and control center. So then the idea came about that why don't we think of a device, a sensor platform, which can be sandwiched between the streetlight luminaire and the controller. Now you can choose which pole you would like to put it on. So if you have thousands of poles, you can choose, and maybe 1 in every 50 or 100 poles you have a sensor platform. Now to this sensor platform, which we call the Near Sky 360, you can connect the data output of many other devices. One of the things happens to be traffic density monitoring. So you know that which lane is having more of a traffic, etc. The data goes in real time, it gets processed in the platform and gets across to the command and control center. The other one, for example, toxic gases, environmental sensors. And even tomorrow, what we talk about as, with electric vehicles being promoted by the government, you will have EV charging stations and you have many of these poles, maybe 1 in every 20 streetlight poles is a smart pole with chargers and everything. Now again, capturing the data from this, you need to communicate. Now one way of doing it is that you have individual communication channels or protocols for each of these sensors. The other easy thing to do is you have a prevailing network which is anyway available to you. So why don't you use the same communication that takes place? Like for example, in the case of street lighting, we use a lot of Zigbee in India because the proximity of the poles is such that the mesh network gets formed just similar to a Bluetooth. And then you're able to communicate it, and you have the hopping. It doesn't require line of sight in every case. So you can easily communicate the data, and then this data gets across to the command and control. So essentially, the concept is to use the lighting network, the lighting as a backbone, and carry the data of multiple sensors, can be a garbage bin. So you can have a RFID on the garbage or a Bluetooth that can get registered out on the sensor platform. It processes and sends the information saying the bin is full, not been cleaned, etc. So it's just a question of what you want to which sensor you want to use. You have a whole plethora of sensors, a complete umbrella you can call it. You choose it, you use the lighting backbone, which is anyway going to be set up in every smart city across the country, and then you carry the data across to the command and control, and then thereby add value to the overall services. That's in brief the concept.
Great, thanks Shiva. Okay, so what I'm going to do is before we go to the audience, I have what you call is a very quick question. So you're going to get only 60 seconds, everyone. And it's going to be a kind of a realistic question. All of you are actually SIs or OEM technology providers. Tell me one project in one city, any city in India, you would like to do it, and what do you need from government? Arul.
Okay, so I would call it a level playing field in terms of engagement, in terms of being open to suggestions by technology partners. And I don't mean a particular company. There are a whole lot of organizations even represented here. We need a level playing field to be able to deliver, and the ability to showcase the value adds. If, as you know, the trend is only for,
Anything specific, Arul?
So the entire domain of the cognitive or the security domain, that's another area that, remains unaddressed in this entire aspect of connecting cities. These are areas where there is a lot of, there's a whole spectrum of technologies that is available, right? And currently, most of the requirements treat, the entire spectrum at par. Now, there has to be a evaluation of technology.
One ask, Arul. One ask.
Okay, so I'd like the evaluations to be more based on quality rather than just a cost case.
Okay, great. Ali, I saw Amritsar, it's brilliant, but anything else you want to actually do? One project, one thing?
Yeah, so for us, a project is infrastructure. We deploy the gateways, the towers. So what's great about what we can do is, let's just use NDMC. That's kind of my passion focus, being hometown here. Our infrastructure project would support facets of different use cases and solutions in the same city. So what I would like to do is have the opportunity to have open-ended discussions with the government decision makers so that we can leverage their infrastructure to support our deployments, which will then support 70 to 80% of their overall projects. So that's something that's really interesting to me. I think it's be cost effective if smart cities do that. The other thing is easier access to the decision makers so that we can do maybe workshops, education at the levels that's necessary so that they have more information to do those informed decision making.
Okay. So you have two asks. Okay. Steve, the same question. So you have already, you've shown a great example of a house smart. Martin, I'm so sorry. My Australian partner is Steve Woolley. So I'm just...
Steve is a perfectly reasonable name. I'm happy with Steve. We'll just call me Steve from now on. It's okay.
Okay. Martin. So we saw the kind of a work that Bluetooth as a technology can deliver. But how will you do it? What's the kind of environment and the system integration capabilities required? What is that you need from a city to do it for you? Because it's mainly going to be a retrofit for a building. I'm not talking about the new buildings. I'm talking about the existing city's buildings. So how do you go about doing it, and what do you need from the city?
Lots of questions in that question, I think.
Only 1 minute.
Yeah, so I better talk quickly. So first of all, let me tell you where Bluetooth factors in smart city requirements. Very broad set of requirements. 4 headings to think about. Smart buildings I just talked about. Location services is a second big area for us. Bluetooth beacons are out there today providing indoor navigation capabilities in complex buildings and point of information, proximity solutions in buildings like museums and art galleries and places as well. We're important in transportation and ticketing. You walk into a station, you automatically have a ticket just by being in the station. And we're also being used for crowdsourcing of sensor data because almost everyone has a mobile computer in their pocket with Bluetooth and the ability to acquire data from sensors that they just walk by. That's a very cheap and cost-effective way of acquiring data and involving citizens in your smart city projects. Citizens are very important. I think the question was what's involved in retrofitting Bluetooth solutions to buildings. Depends what you're doing, of course, but ultimately you do some design work, you figure out what your network will contain. You'll have some requirements driving that, as you'd expect, having consulted with your customer. You will deploy the various devices in your network, be they lights or sensors or switches or what have you, and then you go through for each device a configuration and what we call provisioning process, using a smartphone application to tell the device, here are your security keys, that's provisioning, you're now part of the network, and here are the things I want you to be able to do, that's configuration, like the publish and subscribe stuff that I mentioned. It's quite a systematic, simple process. Most of the work happens before you get on site. That's the design and thinking process. And there are Bluetooth members of our organization creating workflow tools to support that kind of system commissioning process in buildings.
Who can do it in India, Martin?
In India, I've no idea. I don't live here, so it's hard for me to answer that question. That wasn't a fair question. First he calls me Steve, and now he's throwing me unfair questions. What's going on?
I'm giving opportunity to the people out here. You can be the system integrator for the Bluetooth technology.
I don't know. The interesting thing is that we're actually multiple steps removed from that kind of activity. So we define the technology. It gets implemented in chips, basically, by chip manufacturers and by platform operating system implementers, Google, Apple, people like that. Several steps down the line, you have people who design lighting systems for commercial buildings, for example. Those are the people who will be using tools. There's a whole ecosystem there, okay? Those are the people who will be using tools, dealing with that kind of, what I would call a coal face issue, mining metaphor there, of how you actually install and deploy your systems. Who can do it in India? I don't know. Lots of people. Look in the phone book. Google. You'll find them there.
RP, you talked about one startup, but how do you take these startups to the city? So how do you actually make it happen at the city level?
Yeah, in fact, I would like to take a very practical and very latest example from a different side. I'll complete in 1 minute, don't worry. How many of you have seen the movie Uri, The Surgical Strike? How is the Josh? How is the Josh? Okay, you need some energy. Okay, good. Now, if you recall, in that movie, there was a beautiful example which shows that when they were looking for some solution to track, they catch hold of this intern from DRDO who has developed that flying drone, and it actually changed the whole scenario. And as per the dialogue, it helps us to win the war. Now, what we would need today is we have beautiful minds in this country. Very beautiful minds with very beautiful solutions, very innovative solutions, I'm telling you. The problem is, when they create a solution, they don't get an immediate chance to go and deploy those because our procurement systems or our project systems are so complicated, and you should know it better because somewhere companies like PwC need to be blamed for creating those complex systems, sorry. But what I'm trying to say is, like in that movie, we need some of these innovative minds to come, and one of these innovative minds should get a chance to come and use their systems, and I'm telling you, we will not need anything else from any other country if we are able to do that. That's what I would like to see. I would like to see happening in this country. That will change the way we are developing and we are setting up our smart cities or any other huge projects today.
So Murty, I'd like to ask you.
No, just hold on, Arul. You will get your chance. So, Cybersecurity, how do you actually plan to do your IoT-enabled streetlight project in India?
There are already a few POCs taking place. For example, in Gift City, in Gandhinagar, where these near sky platform is being deployed, where, for example, it is a question of, environment is of course one thing, security is another. We have a system which is like blue light. The moment there is some sort of alarm, immediately the light starts flashing, and because of the spread out and you have the laterals of each of these lights, you can precisely pinpoint where it is required. So these are some of the areas which can be, which can be integrated along with the systems. So the concept is out, the POCs are out. There are in fact some commercial installations we do worldwide in the US, where already some of these have been integrated, for example, with toxic gases, with environment sensors, etc. I think it's just a matter of time before you start employing these types of sensor platform gateways and then make it an integral part of the entire smart city ecosystem. That's how we plan to look at it.
Thank you. Arul, your question.
Murty, what I wanted to ask you was, since PwC, has occupied a lion's share of the consulting domain in the smart cities, the point of what RK brought about, that are cities currently open to innovation in this domain? Are we stuck in a, rut that, there are these 5, 6 problems that only need to be solved? Are they looking at innovation? And are you suggesting any, or are you advising the government in any terms in, incubating these startups or these, new ideas that are coming up?
Great question. So usually moderators don't get chance to speak, so I'll take the last few minutes. So both RP's point and Arul's point, both valid. Procurement systems or the procurement processes in India have been, or in the past were not suitable towards the startups, because one of the clauses says that you should have been registered for 5 years, you should have a profitable, you should have revenue so and so, and all those things, which are the pre-qualifications, so they don't apply. But under the startup mission and the ministry's guidelines to the smart city, it's extremely clear. Projects and the consortium member turnover, which is any startup, can participate and work on this thing. So there are startups like Ajivi who has actually signed up as a consortium with a couple of companies and started delivering projects, and they have almost negligible turnover. But coming to both the questions on is the city doing it? I think there are several cities who are doing it. There are several cities. I've talked about the mosquito-free city. 2 cities are running a pilot, and very, very unknown cities are running pilots. There are cities who are actually running pilot, for example, on drones, running pilot on artificial intelligence with startups. Gurgaon as a city, it's running on an AI-based governance model. Startups are directly engaging, and the reason for startups engaging is 2. And unfortunately, it's not the OEMs. Okay, unfortunately, it's not the OEMs. 1, the engineering institutes are enabling its students to have a direct conversation. So IITs or any engineering college are getting their students, brilliant-minded students, to have direct interaction with the city and service. The second is cities themselves are building it for entrepreneurship and employability. Because it's difficult for cities to create an economic development or create a manufacturing plant or area to create jobs, but it's easy to actually create enabling environment to get more and more entrepreneurs and the startups to start doing their own. So there are, out of the 100, if you look at the plan, about 30 to 35 of them have already planned an innovation or an incubation hub. About 5 to 8 are already operational, whether it is Surat, Bhopal, Indore, Hyderabad, or whole of Karnataka, which is Karnataka Innovation Program, which is running Chhattisgarh. They are actually, Jaipur, for example, is doing a lot of work. So these are running. Now, startups cannot, the point here is, and that's why I said that the most important thing is missing here is the OEMs. Unless a startup environment cannot actually flourish if you do not have a mentoring body along with it. If you actually have a drones company, he will actually build something which is to a 1.0 or 2.0, but beyond that he would require a technical expertise to grow it. He gets market access, he gets a live environment, but he will not be able to become a meaningful commercial entity till he gets that mentorship. And unfortunately in India, it's only limited to Bangalore, Hyderabad, Pune, Mumbai, Gurgaon. These are the only 4 areas. If you go, and smart cities, 75 to 80% is tier 2 and tier 3. So let's look at reality. Let's not paint the picture in saying that it's not happening. It's not happening because the environment has not been made conducive to make it happen. Okay, so I'll not have, so let's have this discussion afterwards so we can have a continual discussion. What I'm going to leave is, how much time we have? Yeah, 5 minutes. So I'll have 2 questions from the audience, and only questions if there is any statement, I will actually cut the entire conversation in between. Okay, I have one at the end. Only a question, please.
Yeah, sure. I'm Vishwa, I'm from SenRa. I had a question that initially when we had the telecom revolution in our country, after that we had a situation where there was a mobile number portability. So a person was not really stuck by taking a phone number from a X operator, and he could actually later on, if he feels that the provider is not giving me good service, he can switch on to a different provider. It's the similar kind of revolution stage in the IoT industry. Can we, as a nation, or maybe even on a state level, can we kind of generalize that all the IoT devices should work on a X technology so that the smart city CEO today actually wants to have clarity. Should he go in for a LoRaWAN based sensor? Should he go in for a NB-IoT? Should he go in for, there are so many technologies. So he should have the ability and the choice to decide on one technology which he standardizes for across the state, and if the service provider is not giving good service, he does not need to replace those devices. He can just switch on to a different provider.
Yeah, so I will actually put that, and I'll give RP a chance to answer it because he comes from a background on that. But one, as soon as you use the word choice and you said only one technology, you're contradicting yourself. Okay? Just give me a second. So you had the question. Let us give us the answer. Standards allowed. Single technology not allowed. So that's actually the way in which a government procurement mechanism goes. Otherwise, it goes into a kind of a discussion between whose technology and who is owning that technology. So
yeah, no, I just want to add a quick thing which many people may not know. Earlier, we had this problem that a lot of technologies came in and they don't know how to interoperate. But right now, as we speak, I am part of that think tank committee which is being formed to create a interoperable open architecture data exchange between multiple devices in smart cities. It's now renamed as IUDX, India Urban Data Exchange Platform, which is being created by Ministry of Urban Smart City Mission India, and there are corporates helping them with different open architecture standards. The whole idea is every city, they can put any system, it has to be open architecture, it can talk to each other, the data flow and every standard should be very open so that tomorrow we don't get stuck with proprietary. So it's happening right now. In next couple of months, you will see some announcements coming out from Ministry on the same.
The last question. I'll take that.
So most of the smart devices today in the market operate on Wi-Fi networks, and my question is for Martin as to why in the start companies didn't just start with Bluetooth, why they decided to go with Wi-Fi and sell expensive hubs that are required to operate these devices rather than just starting out with the Bluetooth mesh.
So,
Said Martin.
yeah, he's my twin. So I think you're asking me why are companies using Wi-Fi instead of Bluetooth mesh? Is that basically the question?
Basically, yeah.
Okay, Wi-Fi has been around a long time. Bluetooth mesh, the specification was released in the summer of 2017. So following specification release, there's a time period for companies to implement, so it's quite new. I would also say that Wi-Fi and Bluetooth mesh are particularly competing technologies. Bluetooth mesh competes with other mesh networking technologies. The topology is completely different. It's a low power communications topology, technology. It's for monitoring and control applications. Wi-Fi is for larger quantities of data. You can stream video and stuff. Absolutely not what Bluetooth mesh is for. So don't think they overlap particularly. Architects tend to know when they need a mesh networking solution. You don't have the single points of failure that you have in a hub-spoke topology with Wi-Fi type networks, multiple paths, lots of redundancy and so on. So architects would see those as two very distinct choices. And then the question really is which mesh networking technology, not is it mesh or Wi-Fi. And then it's a case of looking at things like scalability, which is all about that radio and how fast it is, how well designed the packets are and so on, real detailed engineering type questions. Not to mention the fact that Bluetooth is in every pocket on every platform, and that's not the case of all the other low-power wireless mesh technologies, which really limits their kind of adoptability. You can't write applications very easily if the platforms you're developing applications for don't support it. So it's quite new still, but the future looks quite good for it, we think. It's been very well received so far.
Martin, you have some last point, something. We are closing.
You're very kind, thank you. Yeah, I just wanted to tell, this is not actually related, I just wanted to give you some information because it's very new. 2 days ago, actually, on Monday, you're the first audience I've told this, we released a new version of the Bluetooth core specification. So the latest version is now 5.1, and the key thing that's in this new release, which is relevant to today, is that there is a new direction finding capability. So 5.1 defines a way in which a device can determine very precisely the direction a signal is coming from. and you can determine the direction 2 dimensions, at least, with respect to a horizontal plane and with respect to a vertical plane, that's elevation, and where those 2 lines cross, that's where you are or where that thing is, to within, say, 10 centimeters. Very precise location technology, new in Bluetooth this week. There you go. Oh.
Yeah, thank you. Thank you, everyone. That was a good discussion, and I thank all the co-panelists and speakers, and Arul will have a discussion outside.
Ladies and gentlemen, with this we come to an end of our session. I now request Ms. Tanvi Sundriyal, who is MD, Madhya Pradesh State Electronics Development Corporation Limited, to please come up on the dais and felicitate our eminent panel. Mr. Ennison Murty, Partner, Smart Cities, from PwC. This is Mr. Sivakumar, Director, CIMCON Lighting. Mr. Ennison Murty, Partner, Smart Cities, PwC. Ladies and gentlemen, please give a huge round of applause to our panelists. Mr. Ali Hosseini, Founder and CEO, SenRa. Mr. Martin Woolley, Developer Relations Manager, Bluetooth. Mr. Sai Arul, Business Development, Public Sector, IBM. Mr. Ravinder Singh, Director, Business Development, Cybersecurity, Digital Transformation, Dell.